additive manufacturing has been a really core part of our prototyping process almost since the beginning. We very quickly found out that the parts that were coming from the 3D printer were still suitable for production. So we would then put these 3D parts into use on the cars, and it's become a really core part of the development process that we now use on the hand control systems. We first got involved with 3D printing in order to evaluate ergonomic changes to our hand controls. What that meant for us is we could 3D print in very quick time different variants of the hand control paddles that our drivers use to race the cars that you see behind me. The process really starts for us when a driver expresses a need for a different variant of the hand controls that we're using. And this could be something as simple as the track that we're racing out that week has a particularly tight hairpin that turns right, and so they need a larger top to the throttle paddle that they're using on the steering wheel. That enables them then to get more lock on the steering wheel and still have control over the hand controls as they're going through that corner. So for us to be able to produce that quickly, to verify the design and then get a production piece fitted to the car, it needs to be a fast process, and that's really the strength that we find in 3D printing. So let me talk you through the process that we use here for prototyping parts using the 3D printer at Team Brit. The first stage, of course, is starting with identifying a need. For us here, generally that comes from one of two places. Either the driver requiring an ergonomic adaptation to the controls, or an engineer requiring a part to enhance the performance or the reliability of the car. Once we've identified that need, we can design the part. Often that's just a sketch on a piece of paper. We then proceed straight to CAD. So we model the part up in CAD, we slice it in something like Cura, and then we can send it directly to the 3D printer to print over here. We use an Ultimaker. These are supplied by RS. They're a fantastic, versatile tool for 3D printing. Complete with a range of filaments supplied by RS Pro, it kind of covers all of the needs that we've got here at Team Brit. So here we've got some paddles that we printed. These were a requirement for a driver from a specific track that they wanted to change the paddle shape. And because we can print them so quickly, we can really iterate through different design stages in a really fast way, which means that the process is not only straightforward, but it also means that we can get the part on the car as quickly as possible. The main thing for us in this situation is to check the fitment as well on the parts of the car. In this situation, these parts aren't suitable for production and they're not suitable for use in the car. Allowing us to check the fit and the feel of the part on the car is really important before we then proceed to make them out of something like carbon fibre, or in some cases machine them out of a metal. So we're looking here at the parts that we've just printed, and there's a couple of things that we can learn from this. We're always looking at how the parts have adhered to the bed. That's a really important part of the 3D printing process. If we've got parts that are lifting around the edge, perhaps we need to look at the design process again in terms of the 3D printing slicing settings, or perhaps we need to use an adhesive on the bed to make the parts print flat. These ones look like they've come out really well to me. So the parts look great, they've come out really clean. This is printed from PLA filament, which is a really easy printing filament. It's not particularly hard wearing and generally not something that's suitable for production parts that we would use on the car, but it's really good for checking the fit. It's also really good just for assessing the dimensions of the part. So now we know we're happy with the fitment and the design of the part, we can proceed to the final stage, which is of course getting the mould prepared and getting the part manufactured out of a carbon composite. This is something here at Team Brit that we outsource to a specialist company, but we can look at those moulds and show you how that's done. So here we see the moulds that have been manufactured to produce this part from carbon. It's quite a specialist task to produce these moulds. The engineers that are designing them need to understand really how the finished article is going to come out of the mould. It's quite a difficult task really getting it right, and we're really interested mainly in tolerance of the part here, but also the surface finish and the strength. So the prototyping phase is finished and we've got our final part back from the manufacturers. So let's fit it to the steering wheel and just check that we're happy with not only the finish of it, but happy with the tolerance and the locations of the holes that we put in there. For a part like this, we're not massively interested in high resolution of tolerance. There's a lot of areas within this steering wheel where we are really interested in having quite close tolerances, but for these paddles we can be fairly slack with it and we can make sure that it just fits. The machining that we've got inside these steering wheels in the assembly that you see in front of me, we can go down somewhere in the region of 150 microns tolerance. That's a requirement, basically to make sure that we've got no play in any of the shafts, that all of the sensors are picking up accurately without hysteresis, but also so that it's just nicely built. So the paddle looks great from here, it fits perfect, exactly what we wanted, and the finish is fantastic. So overall we're really happy with this part. Let's get it on a car and go and win some races. Often these parts that we 3D print for prototyping prove themselves to be strong enough and robust enough to be fitted to the car permanently. And so let's have a quick look at some of the parts that we've 3D printed here in-house and what their function is on the car. Here we've got an air inlet for the engine, so we're gathering that high pressure air that comes in at the front of the car. We're feeding that into the airbox just to make sure the air's got a good supply of cold air. We've got some ducting here at the front as well. It's a bit tucked away, but you can see it in here. This is ducting for the brakes. So this is designed to keep that air funneled towards the brakes to keep the discs and the pads cool and prevent them from overheating. While we're on the subject of airflow, we've got something to keep the driver cool too. So on the roof here, you can see some scoop ducts that we put in there. This just allows that supply of cold air to the drivers to keep them cool. Inside these race cars, it can get really, really hot. Finally, I suppose the thing that you can see here is some sunshades for the driver display devices. These are really simple devices, but in certain conditions can make a real big difference to how the driver reads their data. So the mechanical properties of these parts is really critical, and that's often influenced by the material selection that we use here. And in particular in the automotive environment, we're really keen to look at things like chemical resistance, thermal resistance, and UV resistance. With that in mind, the material that we most commonly use is ASA. So thanks for watching that. I hope that gives you some insight into how we go about setting up a race car. And don't forget to like and subscribe for more engineering insights.